find the inverse. So what we're going to do here is we're going to find the inverse of all of these functions that we see here. So for the first one, in essence, how we start with the idea of finding inverses is we write the equation out. Instead of the f of x, I write a y. And then what I do is I swap my x and my y. So that means I write x equals log base 3 of y plus 2 plus 3. And like I said before, the reason for that is because when I have inverses, I swap domain and range, and my x is my domain and the range is my y's. So that's why I just swap my x and my y. And then I solve this for y. So to solve for y, I'd first move over the 3 there. So this is now going to be x minus 3 equals log base 3 of y plus 2. And this is where it gets a little more interesting for people. Because in finding the inverse here, I'm going to actually take these both sides and plug them into the inverse of the log base 3. And if I just had the log base 3 here as my function, the inverse of that is 3 to the x. I should say y equals 3 to the x. So what that means I'm going to do here is I'm going to take both sides of this equation and plug it into the log base 3 function. And I know that's going to be a little weird for you guys on this one, but that's how I handle it, because when I see log base 3 of x, doesn't matter what it is, what the variable is, the inverse is 3 to the x. So I'm going to plug both sides into the y equals 3 to the x function. And that's really what I'm doing here. Very strange, I know. Takes getting used to. And what happens here is those cancel because they're inverses. So this becomes y plus 2 on the right. And this is what I'm saying. This is what I was saying in a previous video, that once I understand this idea of inverses, we're going to use this to solve equations. So then on the left side, it's just going to stay the same. So that's going to be, I'm doing terrible with the 3 to the x minus 3. And then I'm going to move the 2 over for the last step. So I get y equals 3 to the x minus 3 minus 2. And there is my inverse function. So again, we're going to see a lot of this inverse stuff going on with these equations. So try to get used to that. If you got questions, get a hold of me. Don't hold it up. We'll play around with a lot more of those. You've used inverses like this in the past, and I don't know if you knew this or not, but when you guys had x squared equals 4, when you square rooted both sides, that was an inverse, because what you did here is you had the function f of x equals x squared, and you said, hey, that's x squared. And then your other function, your inverse function, was square root of x. So you took that and plugged it into that, and that's what this is. So you've used inverses before. You just didn't call them inverses. And we have to plug it in here, and it looks like we're plugging it in here. So that's why it's very evident that these are inverses that we're using. Okay, so for this problem now, we do the same thing. So y equals negative 2 to the ln of 3x. Oops. And then I'm going to swap my domain and range. So now this is going to be x equals negative 2 ln of 2y. Just swap my x and y. And then now I'm going to solve for y. So there's a few ways to do this. I can divide by 2, negative 2. So that's going to be x over negative 2 equals ln of 2y. And then I'm going to think about the inverse of ln. Now remember, ln is log base e of 2y is what we're looking at here. ln means log base e. Okay, so the inverse of log base e of 2y is e to the e to the y is a log base of, how do I want to say that? So ln of x is my function. The inverse of that is e to the x. Okay, so what we're going to do here is we're going to plug both sides of this into the e to the x function. So that's the idea here. Very, very strange for sure. Okay, so this is going to be e to the negative x over 2 equals e to the ln of 2y. Now, since these are inverses, they cancel. And this is going to be e to the negative x over 2 equals 2y. And then I divide by 2. So then I get the answer y equals, and I'm just going to write it this way. And hopefully you're okay with that meaning the same thing. And there's my inverse. Okay, let's do the third one now. All right, as you see, we're not getting away from that. I'm plugging it into the inverse here. In both problems, we did the same thing. We just had different bases because we're dealing with different log bases. Okay, so now for the third one. Okay, that's going to be y equals e to the x plus 2 minus 3. Now, if you notice this one's not a log equation. This is an exponential. Well, it's not a log equation, but when I set this up in terms of x's and y's, it's not a log equation, it's an exponential. Okay, so what I'm going to do here is swap the x and y. So now that's going to be x equals e to the y plus 2 minus 3. So now what I'm going to do is move the 3 over. So it's going to be x plus 3 equals e to the y plus 2. And then what I'm going to do here is when I look at the e there, I have to get to the variable above. So I have to cancel that out somehow. So what I'm going to do is the inverse of e to the x is ln of x. So I'm going to take both of these and plug both sides and plug it into the ln function. And then on the left side, it doesn't cancel. But on the right side, it does. Because e and ln, they have the same basis, so they cancel. And this is going to give me y plus 2 on the right. And then I just have to subtract the 2 over. So I get y equals ln of x plus 3 minus 2. And there's my inverse function of the third one. So again, the inverses, if I have an exponential, are going to be log functions, as in this step here. Or if I'm dealing with log functions, I plug them into exponentials like I did here and also here. So something to think about with our new objects, mathematical objects we're dealing with now.